Hello everybody and welcome to exercise 1 on page 58 of the workbook. And this exercise is asking us to estimate the mass of a metal plate. And let's read the question together. So they're giving us a rectangle, x values between 2 and 10 and y values between 2 and 6. That's what that notation means. So it's just describing this rectangular metal plate that we're seeing in the picture. Okay, suppose that the density of that plate is actually given by the formula rho of xy equals x plus y. So we can use that formula to find the density of the plate anywhere. Notice that the density is changing depending on the value of x and y. And they want us to specifically chop this plate up into little squares of size 2 by 2 and estimate the mass of the plate. Okay, well, let's maybe first do the chopping. Okay, so that we can picture that. Okay, so since they want us to chop into bits of 2, this is kind of what it would look like after we divide that into pieces. Okay, and the mass, as we've seen a couple of times before, can be broken down into density times area. Okay, so I claim that what we really want to do here is to take an integral. Okay, not a horribly big surprise since we're in a section that's talking about integrals here. But just to make sure that that's really right, we can do a unit analysis to make sure that that really represents a mass. Okay, so what is rho of xy measured in? Well, in the problem they say grams per centimeter squared. And that's going to be multiplied by area, which in this problem has units of centimeters squared. Notice that if you cancel the units, you get grams, which is a unit of mass. Okay, so that kind of confirms that taking an integral is what we want to do here. Okay, now we're going to use the same strategy that we've used a couple of times, just kind of dividing this into pieces and taking densities and multiplying by areas. Okay, now we know that the subdivisions, or the pieces that we divided this rectangle in, are all going to have the same area. So what I'm going to do is have a big long line of densities and multiply by the area at the very end. Okay, so I know that every square is going to have area 2 by 2. I'll call it delta x by delta y. We'll put that at the end, and then in these parentheses we're going to write down our densities. Okay, and how about if we use a middle sum strategy like we did before? Okay, so the point that we'll choose in each of our little subsquares will be the middle point, and we'll find the density at each of those middle points. Okay, starting with the first one down here. Okay, where is that point? Well, it's the center of the square, so notice that it occurs at an x value and a y value of 3, so we could symbolically write down the density as rho of 3, 3. Okay, we'll get a number for that in a minute. Okay, and then moving over to the square to the right, that occurs at an x value of 5 and a y value of 3, so it would be the density at 5, 3. Okay, and then moving over one to the right, now we're at an x value of 7. So we'd be talking about the density at 7, 3, and you can kind of see a pattern here. Then rho of 9, 3. Okay, and then we move up here, and let's see, that has an x value of 3 and a y value of 5, it looks like. So rho of 3 and 5, and I can see I'm going to run out of space here. Okay, so let's keep writing, and we'll put the delta x, delta y at the end. Okay, and then we move to here, that's rho of 5, 5. Okay, then rho of 7, 5, and then finally rho of 9, 5. Okay, so we're going to add up all of those densities and then multiply by that area of delta x, delta y at the end. Okay, now how do we find numbers for these densities that we're talking about? So for example, rho of 3, 3, what number is that actually? Okay, well remember, we have a formula that allows us to calculate that. So if we want to know what rho of 3, 3 is, for example, let's sneak that in up here. We would would just take 3 for x and y, substitute in, and we'd get 6. Okay, so that's our density at 3, 3. And we go down here, we're going to get 6 plus. Okay, then we come to the next number, row of 5, 3. Same idea. We're going to take 5 and 3, plug it into the formula x plus y that they gave us, and we're going to get 8. Okay, and you kind of get the idea here. Okay, so p of 7, 3, that's going to be 10, x plus y, 9, row of 9, 3, that's going to be 12, and we just keep going. Okay, let me just double check and make sure that I wrote those out correctly. 12, 14, looking good there. Okay, so there's our list of densities, and then we want to multiply by delta x and delta y, and they gave us in the problem that both delta x and delta y are 2. Okay, so last thing to do here then is just to go ahead and do the arithmetic here, and if you do that, you're going to get 320. Notice that we already came to the conclusion that our unit should be grams, and so that turns out to be our best estimate of the mass of the plate.